30 members and growing fast. Our aim at this community is to bring together some of the best engineers in the cloud native space, period. And we're super passionate about cloud native open source technologies and super passionate about trying to give back and do our part for this community. So I invite you to join our meetup if you haven't already. We're based in San Francisco. All are welcome. So it looks like we have about half our audience is coming from Eventbrite. So this is really for you. Please feel free to join our community and we'd love to have you. Also, if there's anybody who is interested in speaking, if you have a topic, you're working on a great project, something you're passionate about, please reach out to me and let's have a conversation about that. Happy to see if it makes sense. We're open to, all of that. And it really doesn't matter the level of experience. So reach out to us, let us know. Yes, this will be recorded and we will share this with everybody probably within the next couple days. So the agenda for tonight is we'll have introductions. We'll do, Lakmal will do a presentation and then he's gonna do a demo and then we'll have Q&A. And so feel free to ask questions throughout. Don't be shy. So we have a question box and we also have the chat function there. But put your questions in the Q&A box and we'll take those as we can. So tonight's topic is automating microservices to APIs by using Kubernetes Operator pattern. Our host for this evening and our usual host, Daniel's back. Welcome back, Daniel.
Thank you, Josh.
He's currently the head of customer service or customer success, not customer service, customer success at Styra, the founders and maintainers of Open Policy Agent, a graduated project at CNCF. Previously, he held sales engineering roles at PagerDuty, App Dynamics, and DataStax. And he also has an extensive background in client-facing trading technologies at JP Morgan as the VP of Global Technology. So that is Daniel, and I'd like to, yeah, that's you.
I suppose I should I give a little thing on Styra as well while we're here?
Absolutely. This community is huge fans of Styra, and you guys are doing some amazing things. So yeah, please you guys are doing good. Give us an update.
Yeah, well, you mentioned the Open Policy Agent, and you mentioned that we graduated recently from the pipeline at CNCF. That was a big deal. We had a lot of good vibes coming in from around the world in that one. It was super fun. But really, we're the founders and maintainers of that project. And we built a commercial product as well around it, the declarative authorization service that acts as a unified control plane for operationalizing Open. So that's what we do. And Josh mentioned I'm director of customer success. So if and when you do become a customer, I handle all things after the point where you sign your name on the dotted line. So that's me and that's us. But pleasure to be here.
And if you have,
yeah, what's that?
I was going to say, if you have any OPA questions, direct them to Daniel.
Yes, actually, that's pretty much my day job, so no problem.
Okay.
Should I introduce Lakmal then?
Yeah, sure, go for it.
All right. So Lakmal Warusawitana, which I think I did all right.
Yeah.
Not perfect. But he has a long history of working in open source and cloud and DevOps, a bunch of other things. And you were the vice president of Apache Stratos, the platform as a service project. That sounds very interesting. Lakmal contributed a bunch of cloud native open source projects, including WSO2 Kubernetes API Operator, which I suppose will be deeply relevant for today. And you're really about reducing the complexity of API management systems. You presented at a bunch of events. You're an old pro at this sort of thing, so let's get into it. And just to reiterate what Josh said, please ask questions in the Q&A segment, in the chat. That's all fine. The Q&A stuff will get it surfaced more quickly, and we'll just do those as we go along. So yeah, Lakmal, it's all yours. Let's do this.
Yeah. Thanks, Daniel. Thanks, Josh. Okay, let's start it. Okay, so to meet the customer demand, like companies like Uber, Netflix, Google had to build complex systems. If you look at how these companies have evolved, they have increasingly disaggregated their architectures in order to scale. This is a continuation of a trend that we have seen over 5 decades. Massively disaggregated approaches like microservices, serverless, and APIs are becoming the norm for us all. And in general, the greenfield developments happen when you start a brand new project, as in a clean slate development. No legacy system was lying around and no old development to maintain. But in my experience, actually, greenfield projects are quite rare in business application development. Almost always you have to interact with some legacy systems and perform integration with them. Brownfield development happens when a business decides to develop or improve upon an existing application infrastructure. In such a situation, new business functionalities can be implemented by using microservices and can gradually migrate existing functionalities without doing a big bang re-implementation. Regardless of being greenfield or brownfield, in both cases, APIs are the way to expose business functionalities to consumers, partners, or application developers. These APIs should be secured, managed, observed, and monetized. This required a governance model with policy enforcement. This is where API gateway and API management are essential. And API gateway can be used as a policy enforcement point of API governance while working in sync with API management capabilities like lifecycle management, traffic control, policy control, and identity and access management. And to get the real microservice benefits, these API gateways should be evolved with the microservice architectural concepts. That's where a special type of API gateways, that is mainly micro API gateways, will be used for policy enforcement. While having all good things in microservices, it has its own challenges. Because this disaggregated architecture, the number of endpoints is explored. Then the service discovery, network resiliency, and secure communication are some of the key challenges that developers have to deal with while solving their real business problem. In addition to these developers' challenges, DevOps or operational people having a separate set of challenges. They have to tune their deployment engine to roll out frequent releases without disrupting the end users. Also, increasingly, the number of endpoints means tracing and debugging a runtime issue will be harder and harder, and it required extra effort to put observability and monitoring tools in place. So if you look at Kubernetes and its ecosystem are able to provide a way to solve many of these challenges that we discussed in the previous slide. Container orchestration and management and auto scaling, auto healing are some of the key out-of-the-box capabilities that Kubernetes provide. But in my point of view, Kubernetes is not just a platform to manage containerization application, but it is a platform to build domain-specific platforms with more capabilities. Because of this, we can see many platforms that build on top of Kubernetes. Service measures like STO, Linkerd, and serverless platform like Knative are some of the popular platforms that build on top of Kubernetes. The last 15 years, we have worked with more than 1,000 enterprise customers and helped their digital transformation journey. With the emergence of microservice architecture in the last couple of years, many customers start to develop microservices and expose their business functionalities via these micro API gateways. But in this new journey, they had to face a new set of challenges, especially how to automate the deployment by creating Docker images, Kubernetes artifacts like deployments, services, config maps, secret, HPS, and so on. In many cases, they have to hire new skilled developers like DevOps in addition to the business application developers. So this leads to a roadblock for many of our customers, and we started looking for a solution to hide these deployment complexities and improve and empower their developers. So while brainstorming, we noticed that Kubernetes has nice extension point where we can extend Kubernetes out of the box capabilities through this operator pattern. A customer resource is an extension of the Kubernetes API, and once the customer resource is installed, users can create and access its object by using kubectl, just as they do for built-in resources like pods, deployments, and etc.
Would you, Lakmal, for the purposes of the audience, would you talk a bit about what the operator, how the operator pattern came to be? Was it something intended by the Kubernetes designers that came later, or was it built by a team to solve this problem specifically, or was it an accident? How did this happen?
It is coming from the architect itself. I think Kubernetes 1. If I remember correctly, Kubernetes 1.7 onward, this custom extension is available in the Kubernetes platform. But we can see nowadays people are more creating these custom operators, custom resource definitions, and try to automate their deployment as much as possible. But it was there from the beginning, and it was used as production in 1.7 onward, if I remember correctly. Yeah, so you can write Kubernetes operators in many ways, but the operator framework, that's again CNCF sandbox project, if I remember correctly. So that provides a set of developer tools and Kubernetes component that aid to operator deployment, development, and its management. So we use operator framework to create our operator. And also, so operatorhub.io, again, is a home for Kubernetes community to share their operators. And it provides a catalog of existing operators, and also guidance for the contributing new operators. You can see this is a screenshot I took from the Operator Hub. So there's more than 186 operators are hosted in this Operator Hub at the moment. And we have seen.
Just so you know, I looked it up because I wasn't sure either, but looks like the Technical Oversight Committee approved Operator Framework to be a incubating project. So I graduated a few months ago.
Yeah. Okay, I didn't know that. Yeah, we used sometime back. Yeah, it was a sandbox. Yeah.
Yeah. No, exactly. It's new. It's definitely not graduated. I wasn't sure where else it was though. We encounter it time to time in the field, but it hasn't quite exploded. We're sort of seeing the forefront of it at the moment. Yeah.
Yeah. So that's a good thing. So we have seen this trend that Kubernetes communities as well as the platform vendors now actively developing these new operators to hide their platform complexity and improve the productivity. Yeah. So so in WSO2, we developed a Kubernetes operator for API management platform. So in this operator, we have introduced 4 custom resources. The security custom resource hold security related information such as a basic auth, OAuth2, JWT, and so on. And rate limiting custom resource holds rate limiting related information, throttling information like throttling tiers. And then the target endpoint custom resource hold endpoint related information, and API custom resource hold the API related information. Now, the API developers use open API definition to design and create APIs. So they can use same API, open API definition to invoke these custom resources and that install in the Kubernetes cluster. Then the custom controllers of this operator is triggered and it is initialized Kanika job to create API gateway Docker images and pushes to the configured Docker registry. Kanika is again open source project. I think the main contributor is Google. So that using Kanika, you can create Docker images from the Kubernetes cluster itself, and you can push it to any registry. After that, it created relevant Kubernetes artifacts like deployment, services, HPAs, with corresponding to the API definition. So as you can see that API operators have taken out of all the complexity from the developer and the DevOps by automating deployment with all the best practices required for the micro gateway development. Yeah, so I think we have shared a lot of theoretical information. Let's move into demo and see the live action of these things. Okay.
You're going to show us this API operator in flight.
Yes. So I already installed API operator in my. Let me try to share my whole desktop here. Can I share this one? Okay. Yeah. You can see my desktop, right?
Yep. Gonna have to.
Okay.
Gonna have to widen my Zoom window to accommodate. That's you got a dev monitor. That's for sure.
Yeah, I have this. Okay, let me.
Yeah.
This thing. And okay. Oh, you can you see my?
Oh, you're good.
Thing?
Yeah, you're good.
Okay.
Yeah. At least on mine.
So okay. So here, so I have running Kubernetes in my desktop itself. I use Docker for Mac. So here, so I am running Kubernetes inside my Mac. So I have installed API operator. So I will in WSO2 system namespace. So API operator again deployed as a deployment and set of pods and the services. So it's running inside the Kubernetes itself. And when you install API operator, we have to set some role binding and cluster binding permissions so that it can trigger some deployment automatically. So you can see this is a custom resource definitions that are running, and this is the controllers relevant to that custom resource definition. So this is running in the WSO2 dash system namespace, and also I am running WSO2 API manager in a WSO2 namespace. It's a dev portal. So I will explain while the demonstration. So dev portal is how developer can discover and get token to access these secured APIs. So it's running in different namespace. And for the first demo, first what I'm going to do is there's a microservice already running in my cluster. That is the this product microservice, and for the demonstration purpose, I expose that product microservice as a load balancer type, so I can invoke even my localhost machine. But in production case, it shouldn't be the case. We have to expose as a cluster IP. And for the first demo, so that's already running microservice. And what we want to do is we will get open API specification for a micro gateway and pass that into the operator. Then it will automatically create a Docker image and Kubernetes artifacts like deployment, service, and HPA, and deploy automatically into the cluster. So that's the first demo. So in that demo, there's only API gateways deployed, and it will connect to the existing microservice. So for that, so this is the second definition. Let me. Where's this? Okay, you can see my screen, right? This is the generic second definition. So the only thing is you have to notice that the backend endpoint, it's configured as the HTTP//product. This is because we want to expose this product microservice, so we can access using service name that running inside Kubernetes cluster. So this is how it connect the backend, and it will create two resources, that is products and product/product ID. Then you can invoke these two resources and get the response. And before doing that, I will just invoke this microservice and show you the response here. So I'm going to just invoke my microservice directly. So it will return the response with the JSON. Now let's see how you can create, how you can invoke the open API operator and create this gateway automatically. So to do that, so I'm going to use this API CTL command. So again, that's coming with WSO2 API management system. So it can use this CTL command to interact with this API operator. So here I'm just passing I'm giving the API gateway name and passing the Swagger file. And I will going to invoke this API now. So now you can see if I use kubectl get all this thing, you can see there's a Kaneka job started. So it will start to create Docker images out of this Swagger file, and it will then push these Docker images into the Docker registry. And then after that, it will pull and create a deployment automatically in the same Kubernetes cluster. So it will take like 1 to 2 minutes, depending on the machine speed and network speed. Since I'm running in my all of clusters and all these things in my machine, it will take at least 2 minutes. So let me see. So, and this is the Docker hub that is going to be pushed. So let me see. So it will. So this is the Docker image we want to get pushed. So I tested this 2 hours ago. That's why the 2 hours ago the Docker image is already pushed. Let me see how this is running now. So it's still Kaneka job is running. It's when it's complete, it will show that it is completed as it is show as a completed task in the Kubernetes port spec. Give you some seconds. Still Kaneka job is running. So let's
So
give
what,
some.
what are we looking for here? We're looking for this, the
Yeah,
Kanika.
so we
Yeah.
are looking for the Kanika job to be completed, and then there should be a new deployment start with online store with the gateway and the
Okay.
single ports running inside that deployment.
So we're waiting for your laptop to catch up, basically. There you go.
Yes, yeah, just Kanika.
Was your fan running pretty hard?
Yes, yes. I'm hearing the fan sound now. Yeah, so Kanika job is completed, and then the deployment is creating. Now, if you look at the Docker Hub, you can see the online store Docker image is updated a few seconds ago, and now the gateway deployment is already running. So we can invoke the gateway now. Let me invoke. So first I will invoke without getting a token to get you more clear on this one. So if you invoke this one, so that's said that missing credential. So we want to get a token and invoke this gateway to access this microservice. That's how the API management working. To get the token, so I will for the first one I will just use this. This is the developer portal that developers can subscribe and get tokens. So here I'm going to just subscribe and get a token. So I'm going to subscription. So I just subscribe, and I want to go to the token page to get a token. Okay, yes, I got a secret token. Now I can use this token. Say token. Now I just put into the token environment variable. Then I will invoke by passing the token as a bearer authorization header. Now you can see you can get the response with your authenticated using the API gateway. That policy and security policy enforcement is happening in the gateway. And also if you use kubectl get API. So the API is now first class citizen in this cluster because we have installed custom resource definition. And now because of that, we can use get API or describe API to view what's this API and what is uptime, and you can do whatever things with this API. That's the first demo. So it's very simple. What we did, like we expose the API expose the microservice to API gateway by just passing the second definition to this API operator. An API operator will take care of creating Docker images and deploying into the Kubernetes cluster, enforcing these security policies. Okay, so let's.
Any questions from the audience on this?
Yes.
It's an interesting, yeah, it's an interesting but technical sort of approach. So I'm just curious if we have any questions. Doesn't look like it at the moment. Okay.
No question. Okay.
All right, let's keep going.
Right. Okay. For the second scenario, what I'm going to do is, so like I said, we have another custom resource definition called target endpoint. So you can define target endpoint, and when you deploy target endpoint, it will create a backend service as well. For example, let me take that example. I will go to the scenario. We can do a lot of complex scenarios, but I just want to use a couple of simple scenarios here. So in this one, so this is my target endpoint definition. So what I'm going to do is, it will, when I deploy this target endpoint definition, it will create backend services by using this Docker image. It's same like deployment, but it coming with the API management mindset. That is a target for that API. So then after that, I will use API definition to create API gateway to this target endpoint and do the API management. So let's do that. Yeah, since we have time, so let's do that. So first, I will create this. I'm going to use this same definition to create a target endpoint. So I just use that. So you can see kubectl get target. You can see target endpoint is created. And if you look at now, you can see there's a two pods running with the target endpoint, the definition that we defined. Because of there's a two minimum replicas. Because of that, it will create two pods in the Kubernetes cluster by reading this target endpoint definition. Now, if you want to expose these APIs from the API gateway, you can simply use API definition. This is API definition. And you can see it consuming the backend service as the service name that we define in the target endpoint. And then it will create API gateway. Let me invoke. Sorry. Now, so it again, this is, it will create relevant Docker images with the connect job and push it to the registry, Docker registry, and then create the deployment. So likewise, so we can create, we can have very complex scenarios. We can expose some APIs that running on multiple backend services and do a composition and expose as API. So all these things can handle just passing the second definition into the this API operator. And this same operator can work with platform like STO and Knative. So because of this Kubernetes extension, so all this Knative, STO, all these platform are built on top of Kubernetes. So they also use the same extension point to define this custom resource definition, custom resources and controllers to do what they do in the automation in their deployment. Let's see, it is still running. So it will take like another couple of seconds. Is there any questions until this is going to be ready?
None coming from the audience. You must be doing a very clear presentation, something along those lines. Yeah.
Oh yes, no one can't understand anything.
Yeah, I suppose it could go that way as well.
It goes either way. Either
Yeah.
rip it
Either
in,
way, yeah.
or they don't understand a thing.
Yeah. So let's wait a couple of seconds to this to finish. The next demo is a bit complex. So in that demo, what I'm going to do is so I will create a target endpoint with the mode called sidecar. Then when you create the target endpoint with the sidecar mode, and when you create API definition, it will create a single pod with two containers that API gateway attached as a sidecar to the backend service. So this is a normal service mesh pattern we can see. So the thing is only we can define this thing in the API definition. Then the API operator will take care of the complexity and deploy all this deployment into the Kubernetes. So this is completed, and the API gateway also running now. Let me invoke. So in this case, I just have a built-in token. Let me invoke the without a token and see. Okay, so it gives them missing credentials. And if you look at get maybe services, you can see this yes, product. This running is a cluster IP, so even we can't access from the outside of the network. So, but since the API gateway is exposed as a load balancer, you can access API gateway. But you via the API gateway, you can get the response from the backend service. Now, let me use a token. So I use the inbuilt token for the reduce my time, and now I will invoke by passing this token. Now it will access through the gateway and backend get the response back. You can see it getting the response back via the API gateway. Mm-hmm. Okay, let me delete this setup. Otherwise, my machine is going to be a overload. Okay, the third demo that is the sidecar mode that I'm going to invoke. Okay, so in the sidecar mode, so this is the target endpoint. So again, we have the Docker image, but when we deploy this target endpoint, there's no port create at this point because it should be created with the sidecar when you deploy the API gateway. So it will just create the artifact, just create the target endpoint reference, and it will automatically create the backend service as well as the API gateway when we invoke when we create the API creation call. So let me try to just use that. So now if you look at so endpoint is created, but there's no deployment. This is the previous microservice. There's no backend deployed. And now for the API definition, I will use this second definition. So it has the URL that is what we define in the target endpoint, mm-hmm. and that's the resource, two resources, and the mode is sidecar. So that is the how operator identified how to deploy this gateway and the backend service.
I love the definitions up there, if I may say so. That's just, I haven't used sidecar to refer to a cocktail or a motorcycle in ages. It's all containers now. Wiktionary needs to keep up. Yeah.
Yeah, let me okay, let me deploy the second definition. Mm-hmm. Okay, now if you look at now, it will start creating the new API micro gateway Docker image, and after that, it will create single port with 2 containers. So we'll wait for that. Then you can get more idea. You can understand the idea behind how we can create a sidecar. And again, this Docker images is pushed into my Docker registry. So you can see the previous one is already pushed. Now this one is going to push as well. So the idea behind this, so if you look at even micro gateway deployment, there are different complex deployment patterns. But now, if customers want to deploy or enterprises want to deploy this pattern with their microservices, they require a lot of skills developers to create these artifacts, and so there are a lot of complexity. But so what we have done is we have introduced this API operator. So that API operator will hide all this complexity and just provide the necessary interface. That is the API definition from this platform point of view, because this is an API platform. So API developers know the API definition. So they can just interact with API definition and just pass that into the operator. Then the operator will do the rest of the thing, deploying with the best practices by creating all this necessary artifacts. Even Docker image creation also uses best practices. Like we have seen many customers want to create Docker images, don't follow the best practices. Then end of the day, there can be security issues when you are having the production deployment. So these things can be mitigated by using this kind of automation. And that is the main idea behind the operator. And operator pattern is to do this kind of thing. Even if you look at the STO or this kind of platform, they will do the complex deployment, but just getting the single definition of their services. So that's how the industry is moving forward. That what I am seeing, because Kubernetes is a platform to build many platforms. So that's the beauty of the Kubernetes architecture. So they have placed very great extension point that anyone can extend and create a domain-specific platform.
Yep. So with this operator pattern, you can very easily create an API platform on top of Kubernetes. Is basically what you're saying.
Yeah. So that's what we did with this exercise. You can see the Kaneko job is completed, and this gateway is running with the 2 containers. That is one for the backend services, and other one is for the API gateway. Just use describe and get the deployment. Let me get the deployment. Seda coming out in university. Okay, so I think we can use this. I'm not sure what's why is this computer is giving.
Did something go wrong with your cluster due to it being on a laptop? Like, did it run out of?
Yeah, I don't know. It's just maybe overloaded now.
It happens.
So I think that you got the idea. So basically, there are different deployment pattern, but we can just hide the complexity by using this operator pattern. Okay, so if you finish off with the takeaways, right? So if you look at the microservices help to increase innovation to the agility, and now
we have a suggestion from the audience to do kubectl describe deployment, and then.
Okay, I missed that.
Yeah, I think it was just a little typo then. There you go.
Yeah.
Thank
I
you.
understand.
Thank you,
Thanks.
anonymous attendee. Yeah. Josh, how many anonymous folks? I don't see them in the list, so I don't know how many.
either. Somebody snuck in there.
Yeah.
Sneaky person.
Yeah, well, thank you
These
for
things
that,
happen,
whoever
right?
you are.
Yeah. So when you have a spotlight, you can see
We need
the
to hire
issue.
that guy. Let's hire that
Well,
guy.
that's the thing. We only see the named folks in the attendees list, so I have no idea who that was. It was,
Yeah.
oh, okay. Sridhar, thank you. It's funny.
Sridhar. Thank you, Sridhar.
Yeah, so this is that's running two containers in the same pod for the sidecar mode. Okay,
Appreciate
so
it. It's
the
it's
takeaways.
inevitable in any live demo, something has to go wrong, and there you have it. That was the thing that went wrong.
Yeah, that's true. Yeah, so the takeaways is Kubernetes is not just a platform. It can be used to build up another platform, that domain-specific platform, and we can use this operator pattern to hide the deployment complexity and increase the productivity in many cases. And this is why the many vendors or developer communities create these operators and use their deployment, Kubernetes deployments. Okay, so this is what I want to share today. I think if there any question, I can take.
Don't see any coming through, but last chance to talk to Lakmal here if anyone has anything. Okay.
Going once. Going
Well,
twice.
Josh, I think I'll say thank you very much, Lakmal. I was looking forward to this one, and I appreciate you taking the time to put this together, and of course for being here today. Josh, do you want to take us away then?
Yeah, Lakmal, thanks so much. Thank you, Daniel. Really appreciate your participation. Lakmal, I know you put some time into this, and thank you so much. So just so everyone knows, Cloud Native at Scale meetup group based in San Francisco. Our next event is going to be on GitOps and progressive delivery with Flux, Istio, and Flagger. And that's going to be on Tuesday, April 13th, same time with Marco Amador, and he's the lead data engineering and SRE at a company called Innova, and they're based in Portugal, actually. So he's going to join us via Zoom. So that's all we have for you. If anybody has any questions, wants to bring up a topic, wants to be a speaker, don't hesitate to reach out to us. And Lakmal, what's the best way to get in touch with you in case anybody wants to reach out?
Anyone can reach Twitter or LinkedIn. Yeah.
Okay.
I'm available in both platforms.
Great. Yeah, me too. So you can find me on LinkedIn. And what about you, Daniel? What's the best way to reach out to you?